Today on My Climate Journey, our guest is Giulia Siccardo, Director of the U.S. Department of Energy's Office of, and this is a bit of a mouthful, Manufacturing and Energy Supply Chains, or MESC. Today's conversation is all about how the U.S. is trying to onshore manufacturing of key clean energy supply chains, things like EV, battery metals, and the like. We start out with a bit of a history lesson on why manufacturing somewhat intentionally moved offshore from the 1980s through the 2010s, and the implications of this move on the American workforce. We then talk about how and why MESC was formed and the initiatives and programs that MESC is undertaking to swing manufacturing back within America's borders. To give you a bit of the detail before we start the conversation, MESC was established as a new office in the Department of Energy in 2022, with the aim of strengthening and scaling America's clean energy supply chains through investments in manufacturing capacity, investments in workforce development, and data analysis of America's supply chain vulnerabilities. Giulia joined the DOE after many years with McKinsey, including having led McKinsey's Green Growth Service line and having co-created Frontier, the advanced market commitment to buy over $1 billion of carbon removal. And with that, I think we should dive into the discussion. But before we start, I'm Cody Sims.
I'm Yin Lu.
And I'm Jason Jacobs. And welcome to My Climate Journey.
This show is a growing body of knowledge focused on climate change and potential solutions.
In this podcast, we traverse disciplines, industries, and opinions to better understand and make sense of the formidable problem of climate change and all the ways people like you and I can help. Giulia, welcome to the show.
Thanks so much, Cody.
Boy, domestic manufacturing, that's a hot topic. I can't wait to dive in with you.
It's becoming a usual word now, and it's not one that's been really part of the American story for a couple decades now. After the Industrial Revolution, a lot of innovation and invention around industrial processes was absolutely happening in the U.S. From textiles to rail, so much of that has a root in our history. But certainly over the past few decades, most of what's been manufactured has been manufactured overseas. And probably if a lot of us look around the room, most of the things that we look at were made in the US. And that's, certainly been a big shift. A lot of what I'm working on is part of a reindustrialization of the US, doing things, of course, a bit differently, but bringing a lot of manufacturing back to the US.
I'd love to understand and maybe start with that historical context. I want to obviously let people know who you are and what you work on and all that sort of stuff, and we'll get there. But let's just dive right in since you've already started there. What was it about the policies of the 80s, 90s, and 2000s that caused the shift of manufacturing out of the U.S.? I mean, the U.S. is famous for building great, huge things, especially during the 40s, 50s, 60s, giant projects, interstate highways, et cetera. And then, clearly there was a huge initiative to move manufacturing offshore. And I think to capitalize on being more of maybe a financial services and knowledge-based economy. Can you share a little bit from what you've uncovered now, being in the DOE, what you've uncovered as to why that might have happened? And then we can get into what we're doing differently now.
Exactly as you pointed out, what we saw happen in the 80s and 90s was some pretty pure economic theory at work, specializing in each country, kind of specializing in manufacturing and producing the goods, services they could do, at the lowest cost. And so we saw a lot of, even, incentivized through policies like NAFTA, a lot of jobs around manufacturing moving to lower cost countries, where the cost of living is lower and labor intensive activities were more affordable. So, everything from refrigerator manufacturing to automotive manufacturing, a lot of that, moved around the world to places outside of the US. And I was trained as an economist in undergrad. I very much appreciate the economic theory and, what it can create. A very important law of economics is, one that a lot of these shifts actually create externalities. Around the movement of jobs and the movement of manufacturing, there's an equilibrium that in some cases you cross. You become so specialized in a particular area and, another country becomes so specialized that you're fully dependent on that country to provide the goods and services at the volume that you need them, when you need them, with the responsiveness that you need, and, with some level of security. all of us, of course, experienced during the pandemic. We are needing things to come from the other side of the world and borders are closed. Even when, countries are trying to move goods and services around, that becomes a lot more challenged. In our current moment, there's a bit of a realization that we want to operate in a global world, and we absolutely should be. And, we should specialize and, each country produce to their advantage. However, we also need to keep in mind, where that equilibrium is. And, when we're crossing to a point of then being fully vulnerable, and particularly if that's happening with a trade partner that's not fully reliable for the U.S. And so a lot of what my team does from the supply chain side of things is actually look at where are all of the products that we need coming from. If we look at just today where we stand, supply and demand snapshots, where are there shortages or emerging shortages? And even in the areas where there aren't shortages, where are we, procuring components, procuring raw materials, or the finished product itself, in by and large from countries that, might not be reliable trade partners now or going forward? And how do we kind of shift the balance from that so that we can operate in a stable energy economy?
Let's take China in particular, sort of the unnamed partner there that you were alluding to, I think. I mean, the U.S. has had a trade deficit with China for a long time now, by design, as you sort of laid out during maybe not less the 80s with China, but 90s and 2000s. And yet today, it's really interesting as we think about moving to a clean energy economy. China is the leading manufacturer of solar panels, for example. They own a large chunk of the supply chain around critical battery metals. There's a bunch of news lately about cheap EVs from China, and obviously the U.S. just dropped large tariffs on those coming into the country. So there's clearly also a tension between can and should we build stuff internally, and how fast can we deploy clean technologies? Some duplication of supply chain, in theory, I would think, may also slow down clean energy deployment, while also, I guess, on the other hand, building resiliency in the event of supply chain interruptions. So I'm curious, I mean, these are huge, meaty topics, but I'd love to hear your thoughts on these.
This tension is my day-to-day, my team's day-to-day, constantly thinking about how we actually position supply chains to be in a place to be able to grow. If you take the example of Chinese solar panels, obviously having goods produced at low cost, enables them to be purchased and more widely deployed. However, if that pushes to the point of China is, producing twice as many solar panels as they need, we end up being in a place where we're flooding the market with a low cost product and making it impossible for anyone else to build locally. These are exactly the kinds of issues we're tracking, where certainly the answer is not the U.S. needs to build an island and, produce everything that it needs. And if we can't produce it, we won't have it. That's certainly not the answer. But we pay really close attention to, where these trade levels are and, where disconnects between prices are across markets. Think about, for us, our levers are supply related. How can we support U.S. manufacturers to actually construct facilities, even in segments of the supply chain where China has had a big head start and, our manufacturers are subscale or they haven't been invested in before. That's the kind of de-risking that we can do to help level the playing field, in many cases against policy that's been pretty anti-competitive and hasn't given, our manufacturing sector a fair shot.
Classic free market economics would say, hey, capital will go to the highest returns possible. And yet the government plays a role in regulate where needed some of these areas where the free market economy might miss externalities that affect real people in their real lives.
Absolutely. And I'm a capitalist through and through and, absolutely believe, and this is very much the foundation of a lot of our programs and policies, that the private sector needs to lead. Markets are going to fundamentally be right about, where to place investments. However, we do need to recognize that there are market failures. Being able to address those externalities is something that government can do. And a lot of what we focus on is how do we actually set up our programs so that they set off a flywheel. And it's not government needs to permanently intervene, but what are the interventions that government can make that then grease the skids for the private sector, investment community, corporate community to then take actions forward. And so that's a lot of the principles around how my team and I invest in opportunities across the supply chain with our principles of national security and economic growth, which may be a little bit different than, just shareholder returns or, pure IRR. But, how do we create an opportunity and then let the private sector investor take it forward, with that profit-oriented approach?
It strikes me that in many cases, externalities, when it comes to supply chain, are a fancy word for saying jobs. If you let one country produce something at a low cost, so much so that you can't afford to compete domestically, you hollow out your own domestic workforce in that sector. And it's interesting, we've seen that play out in real time in nuclear lately, where you had these huge nuclear projects in Georgia with Vogtle. The U.S. hadn't really built much nuclear in a long time, and these projects ended up being way over cost, over budget. And when you talk to people who are close to it, a big part of it is that the trained workforce who had built large-scale nuclear before just didn't exist in the U.S. So a big part of what had to happen was a retraining of workforce to try to build these projects for the first time.
Absolutely.
Obviously, when you're having to do that, those things are expensive. So this is that flywheel, I think, that you're probably referring to, which is the more skilled your labor is, the faster they innovate, the cheaper things might get, the better quality things might get, et cetera, which means supply chain and workforce go hand in hand together.
They absolutely do. They're kind of the two core pillars of our focus. We invest in manufacturing capacity and we invest in workforce. And that is by design. That, needs to be hand in hand. And to your point around this flywheel, when we move forward to invest in a project, and invest in a manufacturing facility, we require companies to share with us, where is the workforce going to come from, the construction workforce and the operating workforce, and kind of do that forward thinking around the plan. And everyone might say, yeah, of course, that's something that everyone does. It's not really something that we do in great level of detail to think about, for every welder, do we have enough welders in the Georgia area to be able to deliver Vogtle? And doing that activity up front actually, positions us to, one, know that the company is actually going to be forward looking about this project, has a serious plan to deliver it on time, which is another issue in our capital project space. But it also helps us work with the company to think about all of the different places that workforce is going to come from. If we look across all of the clean energy manufacturing and new ventures that are going to be required in the clean energy transition, we actually see a net addition of 13 million jobs through that energy transition. And that more than offsets a loss of 2.7 million fossil fuel jobs. So I think there's, a big perception around this energy transition of, the bots are coming for my job. All of this is automated. There's no place for workforce. And that's absolutely not true, both on the construction side and on the operating side. Those jobs are going to transition, and the skills that we need to train for are going to change. And also come back to Vogtle. In the Vogtle story, the unions played a huge part in actually ultimately delivering the project and needed to build up a set of facilities to be able to train more workers around the construction to get the project done. I actually had the opportunity to go down to Augusta and spend some time at the IBEW training facility, which was such a highlight. They actually have set up, imagine a giant basketball stadium. It's all gutted out, and the inside is set up with kind of different areas of commercial facilities and homes. And apprentices can come in and actually train on how to install and uninstall a heat pump, how to wire complex electrical equipment, different gas pipelines, how to install residential and commercial equipment, solar panels, so on, EV charging infrastructure, and how to repair that. It's all hands-on, and they were able to stand up a workforce, which actually one of the exciting facts was that it's a predominantly female workforce that is doing this construction through these kind of new kinds of facilities. And that's the kind of stuff that, one, we want to work with companies to think about, how are you partnering with groups that may not have been part of your operating model in the past, but are going to be a key to training up quickly and to accessing workforce. And those might be unions, they might be community colleges, they might be other trade schools, even, reaching into high schools to educate students about different kinds of STEM and manufacturing jobs, making sure companies are thinking about that. And then we also use some of our capital to actually invest in those kinds of facilities and, be able to expand them and stand them up in places that, are really needing to support more manufacturing. And the great news about all of this delta between the number of jobs that we need and, what we have, while there is a deficit right now, these, by and large, most of these jobs are jobs that we already know how to do now and we know how to train for. We just have to shift the volumes across.
So it's not necessarily nuclear engineering. It's electrical work, it's welding, it's painting, it's...
So much of it is welders, pipe fitters, steam fitters, electricians. We're going to need to add 80,000 electricians per year from now to 2030 to be able to keep pace with the amount of electrification that's happening both in construction as well as ongoing operation. We know how to train an electrician, but we have to make that more accessible and also make that a compelling known career path.
I was talking with one of our portfolio CEOs earlier this week, Chase Lockmiller at Crusoe.
I just saw him yesterday, actually.
Oh, fantastic.
Yeah.
He was sharing with me that you actually just alluded to this whole notion of, are the bots going to eat our jobs? And he was saying, look, from where he sits, they're out supporting the growth of AI-based data centers in the world and in the US in particular. And he said, look, I see AI as actually being one of the largest blue-collar workforce generators since the New Deal, essentially, given the size and scope of the number of data centers that need to get built, and then the amount of clean energy that these data centers are requiring to be built in order to power them. The combination of those two things is just creating a manufacturing boom across the US. I'm curious your take on that statement.
This is actually very similar to the conversation we were having yesterday, but I think it's absolutely true that AI is going to be a multiplier for the amount of blue collar workforce that exists in the US. I think what gets really interesting is around how we think about standing that up in a way that is both efficient, energy efficient, as well as responsible, and where that workforce is coming from and how it's trained. But at the DOE, we know a thing or two about big data centers and big computers. We currently hold the top 2 spots for the fastest supercomputers in the world. One is Aurora at Argonne, and number 2 is Frontier at Oak Ridge. I believe the only 2 computers that are actually operating at exascale currently, and they're massive facilities and they're massive energy draws. When we hear Google saying, it's going to be, 10x more energy intensive to run an AI search, that's going to have a commensurate power need. We absolutely see that, within our own labs, how hungry these machines are. There's a whole set of jobs, most of which we absolutely know how to train for, that are existing around that construction and operation capacity. And then some of what we were chatting about is also, the role of the AI trainer. How does that actually enter into the blue collar workspace? And, how do we continue to train for that? I think some of these flexible training facilities where a lot of that equipment, is there and you can train in a hands-on manner, I think that can really bring to life and, bring this technology into what is, currently a pretty active and innovative training cycle.
When it comes to training for the trades in general, it strikes me that in the US for the last, 50 years, really since the baby boom generation, the emphasis has been go to a 4-year college, get a university degree, major in economics or major in business or major in engineering, build yourself a resume that can allow you to go be in the knowledge economy. Obviously, these were generations that grew up at a time when, as we discussed, manufacturing was moving overseas. And so there wasn't an emphasis on finding a career path, building stuff with your hands and constructing. Psychologically, how do you see that changing in America? Will it change? Can it change? And where should people go if they decide they do want to do something different than a 4-year college?
I'll share with you one of the achievements from last year that I'm most proud of with our team, and it relates to exactly this topic. So my team is a startup within the DOE. We've only been around for 2 years, but one of the programs that we manage has been around for about 45 years, and it is called the Industrial Assessment Center Program. And basically, this is DOE's longest standing workforce program. The idea is pretty cool. You get a team of professors and some graduate students and maybe some undergrads. We share a curriculum with them around how to go into a manufacturing space, a live manufacturing space, and identify opportunities to, manufacture more efficiently, with better technology. The professor and the students go into real manufacturing settings and conduct an assessment, make some recommendations, and the company gets all of that for free. We typically target small and medium manufacturers because they are the backbone of U.S. manufacturing. About 90% of the manufacturing that we do is all within companies, 500 people or less. That assessment is something that then the company can come back and apply to DOE for funding to actually deliver on the recommendations. So all of this stuff, things that have a great payback period, and we can slash that in half and make the payback period even better. So it's a really compelling program. The students get a lot out of it. They go and end up in jobs in manufacturing and in energy after their exposure to this. They all line up great jobs upon graduation. The companies get a lot out of it, and it's been a great program. And so last year, for the first time, and this is the piece I'm very proud of, we were able to expand this program beyond four-year degree institutions. So the program is now inclusive of institutions that represent union training programs, vocational schools, community colleges, trade schools. And this is so important because not all of these jobs are going to require that four-year degree. And we've had this kind of very binary of, if you're going to go to school, you're going to go to college and you're going to get the full degree. And in reality, these are some great paying jobs. They're clean, they're healthy and safe jobs to have. And, they don't require all of that school. We're really in our space, trying to move the needle around how we can funnel students, into exposure around what a clean energy job actually is, and that, we're really inclusive across different institutions through that. This change that you hit on, we absolutely feel that it needs to happen. It's not going to happen if we, ignore those institutions and don't connect the dots to employers. And employers right now need workers. We furthermore, through our community benefits plans and the way that we structure our funding opportunities, we actually, work with companies to encourage them to collaborate with institutions beyond universities to think about where that workforce is going to come from. And for a lot of these companies, it's actually stuff that they're already thinking about, they're already doing. We love to see that. But if we can help plant the seed and move the needle, we've got a huge portfolio and a huge scope. So that's one more catalytic thing we like to be able to do.
It strikes me that hitting kids even earlier, too, like high school level, could be very beneficial. And goodness knows our public high schools across the country could certainly use some program funding.
Absolutely. And a lot of our companies are starting to do that, reach into high schools and even just building knowledge, building awareness. If you study chemistry, that can translate into a job in the battery space. And, you can be developing next gen battery materials. And that's part of the clean energy transition. Just kind of connecting those dots logically for students is something we haven't done across the board. We'd love to see actually companies take that on and go and be present at job fairs or, create events. And quite a few of the companies in our portfolio have done that. And I think we can learn from other countries. Germany has notoriously been famous for starting apprenticeship programs really early. And that works well to have a stable flow of talent. We're keeping our eyes open and, learning from what works.
All right. What is the Office of Manufacturing and Energy Supply Chains? It's new, I think.
It is, and it has a very long name. So we go by MESC for short. We're a startup within government, which sounds like an oxymoron, and it's certainly an adventure to be in that space. But we actually got formed through a reorganization, which is something that also happens in government and, many may not know about. But effectively, when the Bipartisan Infrastructure Law and Inflation Reduction Act passed, what most folks know is that the DOE and the Department of Transportation received, huge sums of money to be able to work towards the energy transition. We decided that, we needed to actually restructure how we were organized to be able to really effectively work with the private sector to put that money to work. The DOE, to back up for a second, has really three parts. There's a part that is focused on building nuclear weapons. And, we won't talk more about that because it's classified. And then there's two parts in the energy world. There's a part that has really been the historic energy side of DOE, which mostly works with research and development organizations. So you may have heard of ARPA-E, DARPA without the D. And then, a lot of our offices focused on actually testing and piloting innovations within energy technologies. Then we had the Loan Programs Office, and we had nothing in between. If we think about the commercial journey of a company and scaling, a lot of the proverbial valleys of death were completely uncovered. We at the DOE were helping out if you, are a smart student or a professor in a lab coming up with a cool concept and we want to promote American innovation and hand you $1 million as a prize. We do that. And then, we'd give you a loan if you are a giant company that is throwing off cash and, able to take on debt financing. But a lot of what we needed to do, particularly if we're going to get back in this manufacturing game, sits really squarely in the middle. So we stood up a new part of the DOE that we brought the Loan Programs Office into, and that's focused on demonstration and deployment. So we've got R&D and then D&D. We've got this full spectrum. So demonstration, you may have heard of the Office of Clean Energy Demonstrations, OSED. They're building the hydrogen hubs. They're investing in DAC. These are big projects, billion-dollar projects, but focused on actually, demonstrating a new clean energy technology and its whole ecosystem. Then you've got us in the manufacturing space. So we're focused on construction, and we're building facilities that are going to process or manufacture clean energy products and their components. And this is something that DOE had never done before, which I think is worth celebrating. Actually manufacturing the stuff and supporting the companies that are manufacturing the clean energy products that we need. This is the first time, DOE has done that. We have a grid deployment office that is working closely with our utilities to get this technology onto the grid. And then we've got our loan programs office. We really, make up these four corners of a commercial ecosystem that for the first time puts us in a place to be helping a company from its real inception to the point where it's raising debt financing and, for the DOE to be present and help it scale at all of those junctures. And we've had some cool stories. There are a couple of companies that got ARPA-E funding, maybe 10 years ago and are now getting a $100 million award from MESC and, moving on to try to get LPO financing. So we're really excited to kind of start to actually stitch that story together. What's worth mentioning in all of these programs, aside from LPO, we are focused on actually co-investing with the private sector. So we make investments at the project level. We're not taking equity in, the top co of a company. We're focused on the plant that it's going to build and, whether we like that particular project. And so if we like it, we will fund up to 50% of the construction. We like to be minority investors in that. Reason being, we absolutely believe in the project, or otherwise we wouldn't do it, but we want to make sure that the private sector also believes in the project, that there is strategic or invested capital, ready to bring that project forward because there's a real customer, there's a real need.
Let's give a theoretical example here. So a growth stage startup in battery recycling wants to build a facility in Ohio and they need $30 million to stand up the facility. It's not quite big enough for LPO to really get involved and give a $200 million loan or something to them because they only need $30 million. And so they would apply through your website to be considered and then could receive up to half of that amount based on criteria you would look at with them. And then the private markets would presumably then come up with half or more of that amount to fund that actual local factory being built out. Am I following correctly?
It's close. We'd ask a couple questions up front because we like to talk in technology readiness levels at DOE. Those levels are 1 through 9. We are not taking on technology risk. We want to take on kind of capital project delivery risk, which is really important. We've got offices south of us that, let's say this battery company or battery recycling company hasn't actually constructed this technology before. This is really going to be a demonstration, the first time that they're building. That might not be for us, and we would recommend them to seek an earlier stage office. But, let's say this is tried and tested. They've got offtake agreements lined up, or at least, some LOIs around that. We're ready to work with them. And we actually have a lot of flexibility around our award amounts. So we, on average, invest $100 million per project, but we'll go a lot smaller in the tens of millions. We'll also go up 500, 600 million. So there's a broad range in what we cover, but our focus is capital project delivery. So this is the first time that we are manufacturing at scale in the US, this technology, this equipment, and we want to be able to de-risk that project so that the private sector investors who are also at the table, exactly as you explained, can get comfortable with that IRR.
So it's certainly not pilot or demonstration plant. It's probably not first of a kind plant, but maybe second of a kind or third or fourth time you're building out this same kind of process.
At scale, commercial scale, that is exactly where we're focused.
Hey everyone, I'm Yin, a partner at MCJ Collective, here to take a quick minute to tell you about our MCJ membership community, which was born out of a collective thirst for peer-to-peer learning and doing that goes beyond just listening to the podcast. We started in 2019 and have grown to thousands of members globally. Each week, we're inspired by people who join with different backgrounds and points of view. What we all share is a deep curiosity to learn and a bias to action around ways to accelerate solutions to climate change. Some awesome initiatives have come out of the community. A number of founding teams have met, several nonprofits have been established, and a bunch of hiring has been done. Many early-stage investments have been made, as well as ongoing events and programming, like monthly Women in Climate meetups, idea jam sessions for early-stage founders, climate book club, art workshops, and more. Whether you've been in the climate space for a while or just embarking on your journey, having a community to support you is important. If you want to learn more, head over to mcjcollective.com and click on the Members tab at the top. Thanks, and enjoy the rest of the show.
And in addition to awarding these are grants, I assume, is that right?
They're grants. You will often hear us talk about them with the term non-dilutive equity.
Okay.
What we mean by that is that they are grants with some teeth. For all intents and purposes, they will manifest as grants, but during the construction period, we actually have some stake in the assets of the project. This is by design. We want to make sure that the project comes online with our, collectively stated goals with the company. So, before we start construction, we'll have some goals around how much is it going to produce and how many jobs is it going to create? What kinds of community benefits practices are going to be in place in this facility? And when we pick a project, we have an amount that we'll name, but the company doesn't get a giant check and, go run off and start digging. We actually set up milestones. And so every milestone is associated with a relevant tranche of capital that gets unlocked when they meet that particular milestone. And the tranches are not uniform. They escalate over time in correlation with the activities that are being taken on. But for that reason, because during the course of really what is a partnership, because, we bring a lot to bear as a partner, as an investor would, more than just capital, we actually, have a bit of a stake in the project. And then once the project gets delivered, we get to celebrate the company and kind of ride off in the sunset. And the whole structure is meant to protect taxpayer dollars, as this is coming up online, but at the same time, not weigh the company down and burden them, because the whole point of this is to catalyze them, accelerate them, and enable them to grow unfettered.
I'm hearing you say stake. It sounds like sort of roadmap stake and sort of process milestone stake, not so much financial stake such that there are debt features to what you're doing where you can reclaim assets or anything, or are there?
So it is actually a bit closer to the latter.
Oh, interesting.
It's a very interesting structure. Of course, if we pull back a bit, prior to any of these offices existing, we had some wins in our investments and some investments that didn't go so well. And it was really the loan programs office that was active, working with bigger companies. Solyndra
Sure.
comes to mind. And, you have cases where, a company will go bankrupt. And so then what happens? So we want to make sure that as the company is growing and as we're partnering with it to deliver the manufacturing capacity and kind of, get to a stable operating place, we have the opportunity to protect taxpayer dollars and bring them back. What that means is that any physical assets that are purchased with the co-investment and, the funding that we are providing during the construction of the project, we'd own while the project is coming up online. But we do that in a way that is flexible and, is intended to just make sure we're all fully aligned. And there are some teeth around that as needed. We hope to not need to use them. And, we hope that we monitor these projects weekly. We're touching base. And so if something is kind of starting to go in the wrong direction, there's a lot that we can do to intervene, before it gets to an unexpected bankruptcy. But this is new. So we're building up our processes on how to work with companies. And, actually one of my favorite conversations that we have with other investors who share portfolio companies with us is how we can actually normalize and standardize our interactions with companies, particularly when we're asking them for reporting. How can we actually, if we're all asking for ESG information or cybersecurity information, how can we ask for that in the same way? And I think this is a very new role for government to be playing, to be investing in growth stage companies. And, there's a lot that we can do to really make sure that they can focus on their core mission, which is, delivering the factory, delivering the product. We can make the rest less onerous. But, that's the kind of new set of initiatives for us.
Super interesting. So as a private capital provider, the thing they would think about if MESC is coming into a deal with them, and again, it wouldn't be equity topco, it would be at a facility level. The way they could think about it is basically their dollars almost go 2 for 1. So for every dollar they put in, their dollars get doubled.
We're the best deal around.
There's some short-term risk to that, only in that if the investment doesn't work out in the short term, you as the private investor can't reclaim the assets for any kind of asset sale. The assets are going to be seized by the government essentially. But as soon as the facility is up and running and operational, that risk goes away. And then in the future, should the thing not work out, a normal bankruptcy proceeding would presumably then flow to the private capital.
That's right. And we work with companies to structure all of our support on an individual basis. So there can be, certain structures that we refine depending on what a particular situation is. But yeah, absolutely. That's right. From a kind of IRR boost point of view, we're absolutely the best deal. And, we've seen that actually. And, what our ultimate goal is getting projects to happen in segments of the supply chain that we've underinvested in or, potentially never invested in because that activity has always happened overseas or has, in a dominant manner happened overseas. So back to our earlier conversation around market failures and externalities, our goal is to de-risk projects to the point that we can start to chip away at some of those market failures and have some thread of domestic manufacturing across areas, which are really essential to energy security and therefore national security. This 2-for-1 deal, it moves the needle and ends up, bringing us new projects that would not have happened at all or, might have taken a much longer time to happen.
So when I think of these big areas, the things that continually I hear about are obviously critical EV and just general lithium ion battery raw materials, lithium, nickel, cobalt, manganese. I hear about copper. I hear about solar panel manufacturing and production in general. What other things are there? What are the big ones?
We obviously spend a lot of time, focused on lithium, nickel, cobalt, manganese, all of the core battery materials. We actually pulled together our view as the department on critical minerals and materials, which really underpins how we identify, exactly where the most vulnerable segments of the supply chain are. But what's interesting about, our energy perspective is that, if you ask USGS, the U.S. Geological Survey, or, other agencies within the U.S. government, what the critical minerals are for their purposes, you get different answers. So copper, you mentioned, is on our list from an energy point of view, but it may not be on other agencies' lists. A lot of what we focus on is, one, how do we have a shared perspective across the U.S. government of, exactly which critical minerals we should be supporting and, with what levers. We also think about across the board where possible, can we build partnerships with entities and countries that maybe create suppliers of those minerals going forward, continue to promote trade in that capacity. But also then, beyond, let's say, new mining, also think about how we can build in more circularity from the start. And so a lot of our investments are also focused on either facilities that are exclusively recycling or also recycling these products. Everybody has that kitchen drawer at home that is, full of odds and ends of, old cell phones and so on. That's a little gold mine for all of us if we can tap into it. Some of our programs are even focused on the infrastructure around that, and maybe some of our smaller programs, but we have a couple areas where we're actually investing in collection points with big box retailers. And so we really look at this kind of whole supply chain. Where is everything going to come from and where should it come from for, the most efficient, most resilient, most sustainable supply chain that we can build?
It strikes me that there's also a diplomacy aspect to this with what countries do we want to have the right kind of alliances with, where these materials don't reside in the borders of the U.S. You can recycle them in the borders of the U.S., but if they don't originate here, cobalt obviously being the heavily used example there. How does that work from a foreign policy perspective and your role therein?
We're very active with the National Security Council and even in indirect conversations with some of our closest allies like Canada and Australia, as well as across Europe. But it really is an international conversation. If we look at critical minerals, they are going to be the oil and gas of the future. And there are a lot more of them. They're in different pockets of the world. It's a bit of a more distributed supply chain than our oil and gas supply chain, which, of course, I don't want to underrepresent its complexities, but we now have, many more different kinds of energy products that we're building for, and therefore many more minerals that we're dependent on. And so we collaborate really closely to, one, understand how do we all, as U.S. governments, respond to industry and support industry and build with industry. Also think about, which gets really interesting, where we site processing infrastructure and, where we site primary mining activity. There can be cases where through existing rail infrastructure or existing pipelines, the answer, if you just kind of keep that island mentality of I've got to build everything here, is different than, okay, I'm going to kind of expand the solution set and, think about what's possible if I connect, a few countries together and, think about their shared resources. It wouldn't make sense for me to build one processing plant on our side of the border and, another processing plant on the other, for example. A lot of the conversation that we're having is exploring the bounds of the possible. And then I would also add, with some minerals, graphite, for example, innovation can be a third lever beyond, new mining and diplomacy around that mining, beyond recycling. In the case of graphite, we have made some very important advances in synthetic graphite, which kind of disconnects us from being beholden to that natural graphite mine. While we certainly need to, address potential environmental issues and, energy intensity around a synthetic process, that does kind of open the aperture to where we can manufacture and certainly opens the aperture for the U.S. We currently, as a U.S. government, have 3 graphite projects that we funded, 1 natural graphite and 2 in the synthetic graphite space. And our natural graphite plant is actually importing from overseas and processing here. So, there are a lot of these new business models that we can explore. And then, of course, material innovation, which again, a beauty of actually having a DOE that for the first time spans R&D and this D&D new side, demonstration and deployment. We're not yet at let's call it the recipe of the cathode and the anode that is, the holy grail and is perfect and is not to be improved upon. We're constantly improving and, figuring out, if we change the balance of silicon and graphite, and, if we change the amount of cobalt, what other materials can we introduce to stabilize the performance of the cathode? And it's that kind of innovation where we've got the, at scale investments, but at the same time are, continuing to keep our eye on where the puck is going in terms of new material innovation that can allow us to meet our current needs, but also position us to move towards actually building out the infrastructure around future technologies too. It's a really fun tension to operate in because we've got kind of really great information coming in on, both sides of that from the companies that we invest in and also from the really exciting research going on at our national labs in these fields.
Well, it strikes me you almost have to take a portfolio approach, right? You don't want to say, the U.S. government is picking NMC or the U.S. government is picking LFP or whatnot. It's sort of sodium ion, right? Like whatever it may be.
And if you look at our portfolio, you absolutely see that. We've made silicon anode investments and, we have a couple of them. And, we're also investing in graphite and we've invested in all sorts of cathode chemistries. We are keeping everything at the same level of scrutiny that I mentioned. So, we want to invest in commercial technologies. We want to make sure that there's customers lined up. But right now we're, particularly in batteries, absolutely in a kind of, multi-chemistry, multi-design world. And, we embrace that and absolutely invest in it.
So we talked about the non-dilutive program that you offer, non-dilutive equity, I think you called it. In addition to that, I think you also administer 48C tax credits.
We do.
Can you share a little bit more about that with us?
So most of what we do are kind of these non-dilutive equity investments, weird term, different class of capital. We're government, so everything's a little bit different. But 48C is an incredibly exciting program, and we actually run it in partnership with the IRS. So 48C actually started out during the Obama era. It was part of ARA, part of the American Recovery Act. At that time, it was about $2 billion. The 48C that we run is a much bigger 48C. It's a $10 billion program. And we've expanded the scope on it too. So it actually has 3 categories. It's focused on critical minerals and their recycling. So exactly what we were talking about earlier. It's focused on clean energy product manufacturing and clean energy product recycling. And it's also focused on industrial decarbonization. This last category is focused on adding any sort of energy efficiency saving technology or green technology to an existing manufacturing plant. And it doesn't really matter what that manufacturing plant makes. So it could be making wind turbines or it could be making baking soda. We don't really care. What we care about is it putting in new technology that is, helping decarbonize its operations. We have those 3 categories. It's a tax credit. So it is a 30% investment tax credit, an ITC. That means that we deliver the funds to the project when it gets constructed. Once the project is, fully delivered, it gets those funds. But of course, we commit to the winners of this tax credit knowing that now. We actually ran $4 billion as a first round of this tax credit that closed earlier this year. And so we've notified the winners in that case. And we have open now the second round, which is $6 billion. And basically, within this year, you'll learn if you've received it or not. And then as your facility is constructed, you earn it back.
I was going to ask, so with the non-dilutive equity grants, I understand that you're reviewing their your unit economics and their financial projections and their workforce development plans and this, that, and the other to decide if they qualify for your program. with a lot of the consumer tax credits, it's like, okay, if you did this thing, you get the tax credit. But it sounds like there's a fairly heavy qualification angle to the 48C credits as well.
That's right. This is not, your mom and pop's tax credit. This is not, the usual tax credit. It manifests exactly as one of our competitive programs does. We look at the community benefits plan, we look at the business plan, we look at what kind of product is it manufacturing and how essential is that to addressing supply chain vulnerabilities that we're seeing. The process looks almost exactly the same, except what you're getting on the other side is a win of a tax credit that covers 30% of your investments instead of a grant. One more thing that is, unique about this program is that there's actually a focus on what we call energy communities by design. In general, we're focused on energy justice and equity. And so, we're always keen to understand if there are positive impacts of the project in disadvantaged communities. But 48C is a little bit different. It's focused on communities where a coal plant or any sort of coal mining activity has been in the works at any point in the past 20 years. That could be open now or it could have closed. But if at any point that was kind of part of the economy at the census tract level, there's a boost in your chances to get the tax credit. So 40% of the funds that we have for 48C are actually reserved for companies that are operating in those energy community census tracts. And we've got the map up on our website, so anyone can take a look at it. But what's really interesting is it actually lights up a lot of the U.S. If you go back 20 years, and many of us, particularly Californians, as I am myself, we wouldn't think that, but coal has been a big part of this country's history in our recent history. So the principle there is really, how can we bring new industry back to these communities and, bring them into a new wave of growth, with this manufacturing revolution that we're bringing back to the U.S.
One other question about the tax credits, which is, do they benefit from the same transferability as many of the other Inflation Reduction Act initiated tax credits?
This is obviously new. We just had our first round, but we're seeing, markets begin to develop around these tax credits. And our goal is to, make sure that companies can access them, but it may actually be worth it for companies to monetize them prior to the project, actually fully coming online. The certification process, moves forward with IRS, but, once that's certified, we're pretty excited to start to see a market evolve around that. The last cool piece about the tax credits is you can actually stack them with the grants. Right now, truly, there is no better time to have a manufacturing project, a clean energy manufacturing project in the U.S. There is so much government support for those projects in a way that can totally transform the economics, particularly when you start to look at, how you can combine them together, if you're at this kind of construction stage of growth.
I hate to have to ask this, but you mentioned timeliness and right now. How should we all think about all this with respect to November and an upcoming presidential election and potential changes in administration and who knows what else?
It's a question we get all the time. It's an election year and it's a particularly interesting one. We're focused on, moving forward on our programs. Once we, move forward and get into contract with a company on our grants, that is a contract between a company and the U.S. government. We've defined what the terms of delivery are. So if the company is, moving forward and meeting those milestones and building the plant and, building the first set of lines and then standing it fully up, that is capital that's going to move forward. Never in the history of the U.S. has a transition of power actually resulted in a change in contracts between the government and other entities. That is something that, I think many folks don't realize. And so we certainly want to share. In full transparency on the tax credit side, it could be possible that Congress goes back and changes the amount of tax credits that are available. This is a competitive process. So having your projects in and get awarded and having a high score, of course, would position you to, be able to retain that tax credit, even if the top line amount gets reduced. We can't posit or presume what a future Congress will do. But right now, our goal is to be as transparent with industry as possible and work as efficiently as possible so that, the programs can get stood up and, we can start to break ground on these facilities and, have them delivering product that we very much need.
Thank you for addressing that. I'm sure it was a question everyone listening to this episode was wondering, so I'm glad we got it out there.
Of course.
I meant to hit at the very beginning of our conversation, and we didn't, was that prior to joining DOE, you were instrumental in helping to create a group that I think a lot of folks who listen to this pod regularly are quite familiar with, which is Frontier, and the work that they've done to be an advanced market commitment for carbon removal. So before you were helping to stand up U.S. manufacturing and support the domestic supply chain for our energy needs, you were thinking about other problems in the climate space and the clean energy space, which is emissions reductions. Just curious how your thinking on that has, maybe give a quick overview on what Frontier is for folks who aren't familiar, but then also curious how now being outside of it and being in the federal government maybe has evolved your thinking on carbon removal and its role in the broader transition.
Frontier, for those who may not be as familiar, is something called an advanced market commitment. What that structure seeks to address is effectively that when a technology or an offering is particularly nascent, there's a disconnect that exists between, the amount of capital that you need to pull forward to be able to construct and kind of stand up a facility, in this case, a carbon capture facility in operation, the certainty that there's actually going to be a market and a certainty that what people are going to pay for the service, because you have this whole chicken and the egg, the service has never been built before. And so we don't know if we're going to buy it. We don't know if we're going to need it. What the advanced market commitment structure seeks to create is basically a promise on behalf of a broad enough pool of companies that they are going to pay for the service when it comes online and at a clearly stated price in advance of, when that service is available. And that certainty, is bankable for the company and allows them to raise the funds and, move forward on their construction schedule to actually deliver the product. It's a really fantastic structure and, one that in the carbon removal space lends itself particularly well, because the space is so nascent and, the demand therefore is so ambiguous. It's also really hard to pull off. Having been part of that process, it's eye-opening. It comes back to, it's one of those economic theories that is so beautiful on paper in textbook. And then, when you do it, the reality is there are a lot of friction points. You have to pull together a lot of different companies that, have different business models and different interests and different time horizons and kind of get them to all want and commit to the same thing, even though they haven't actually worked that much together before, at least not in this capacity to kind of be joint buyers for one product.
Frontier in particular is Stripe, Shopify, McKinsey, Meta.
Yep.
Am I correct there?
Yep, exactly. And so really different, if you look at these companies, and I know more have been added since, but companies, some of them are making physical products, some of them are not. Some of them are squarely in services, some are big, some are small. How do you, normalize all of that and, create a shared operating model and, steering group when, everyone is starting out in such a, different place? It can be done. And, we did it and it's moving forward. And it's been an important first dip of the toe in for the carbon removal industry, and hopefully a lot more to come and, more success on that. But it's not so easy. And so actually one of the things coming into government that I've been thinking a lot about is, the role that government can play in actually standing up those structures. I think it's very different for a group of, 5 or 6 different companies to get together and, get onto the same page. That's going to take time. It's going to inherently need time and, need a process that allows for trust to be built. Whereas, if you have a government structure that is being created from the outset and it's, this is a structure, come in if you'd like, and these are the terms predefined and they're going to be, fair and consistent for everyone. That creates a really different model, one that can be an accelerant. The other thing is that, for some of these products, depending on what you're talking about, take cement, for example, the government can actually be, an incredible source of demand itself for the product. And so it's not just government creating that skeleton, that structure, but actually, being the anchor tenant for the entire system. I think it's 60% of the cement that is kind of transacted in the U.S. comes through some sort of government entity. So, the volumes can be really big. And if we're thinking about, the green cement and, driving carbon removal, through infrastructure, there are a lot of, really exciting tools that start to be open. And, my current role is the supply side of the house. I like to really make sure that we're thinking about both the supply and the demand side of the equation. In some cases, you can't, think about them separately and say, we're going to just build and construct and, we're going to do so without thinking about, how clear the demand signals are, how aggregated they are. And so while it's something a little bit different that I did before coming in, it's absolutely something that I think about a lot, and that interplay between both sides of this coin.
Well, Giulia, listen, I know we've had a really in-depth conversation about lots of different topics. I so appreciate you for joining us and sharing what you're working on, sharing your thoughts on how the country has changed and your thoughts on where we need to be making our investments today. Anything else we should have covered?
The only other piece, if interesting, might be we do a lot of data analysis around, exactly where those vulnerabilities are. So I'm happy to talk a little bit about, how that actually underpins where we're making our investments and also how it kind of shapes the future of this kind of new part of DOE that we're working on. If that's relevant to the audience, happy to chat on that for a little.
Tell us more. Sure. Of course.
All right. Data is a big part of everything that we do. I like to say at MESC, we've got really 3 building blocks. We're investing in manufacturing, we're investing in that workforce, and all of that is underpinned by data and analytics. And we deal in big numbers. So in 2024 alone, we're going to deploy about $17 billion of investments across clean energy supply chains. That is certainly massive. What is, I think, even more exciting is the data that actually gets unlocked, behind that, because we are choosing investments and then, actually monitoring them and partnering with the companies over the course of their lifetime, all the way up through to capital project delivery. That gets at, for us, a really interesting place of learning and analysis where we can understand, okay, and this is a real example. I've got a portfolio company that within about 18 months, constructed their expansion and is, moving towards a ribbon cutting later this summer. So they're going to be fully up and running. What can we learn from that? That can either be one cool anecdote, but at our level of the amount of, hundreds of projects that we're overseeing, we can actually, analyze that in a data-driven way and actually understand, okay, what workforce tactics did they employ to actually, think about developing and sourcing that workforce? How did they think about design and, actually learn from that, not just for ourselves, but also share that back with industry and, with other manufacturers that are looking to build. And that ties back into our root analysis that, I spoke about earlier when we're looking at supply chains and, looking at understanding exactly where those vulnerabilities are. We work with our national labs and, drill into those supply chains to understand, not just, where do we have gaps in supply and demand, but if we break up an electrolyzer into its components and into the critical minerals that were used to produce it. And I look at, manufacturing capacity and material supply and workforce across each of those lenses. I can go pretty far upstream and understand exactly where the choke points and vulnerabilities are. That pinpoints where we deploy our dollars, but then overlaid with this kind of feedback loop of, how quickly we can deliver the projects, we can create not just, where to place the investment dollars, but how to place them and how to shape these projects in a way that they actually come on much faster. This is really different than if you ask anybody, what is the country that is able to, build infrastructure projects really fast? Probably talk about China. We put a lot of money towards it. We fully own the project and the schedule, and that government is able to move forward really fast. And we've seen that in our global supply chains, how quickly China has actually risen to a position of leadership and dominance in both material processing and manufacturing of quite a few different products. What we're positing is a market-driven and data-driven approach, which is very different, but which we think actually can surface ways to build very fast and also build for longevity at the same time, where there's really an opportunity for the private sector to take it forward and it's not kind of permanently subsidized. And so as we think about what is our future beyond this big wave of funding right now that we're in, right now we're in investment mode. What is going to be a permanent part of our value add is around, data and actually being able to continue to learn from these projects and, bring that back to industry.
Do you see MESC as having a publishing arm where you're sharing learnings coming out? Like, what does that look like?
This is exactly where we're heading. It's obviously, very new for us, because we are freshly formed, but later this year, we're going to be kind of sharing for the first time some of this supply chain insight in a more substantive way. And the idea is, this is the type of information that we're looking at. And, we're thinking about how do we invest accordingly? There's a multiplier effect if we can put that out and, share that with private sector investors, with other companies across the supply chain. In the coming months, more to come exactly on that. But, we're building out publishing arm capabilities as we speak.
So perhaps folks listening who are interested in that, following MESC on LinkedIn or something like that would be a good way to stay in touch for now, maybe?
MESC on LinkedIn, also on our website. We have a newsletter as well. We love to bring the voice of industry in. So we've got a couple RFIs that are actually active now. As I mentioned, we work really closely interagency and with the National Economic Council and with the National Security Council. So we love to bring in industry's voice and actually elevate that as we're thinking about what new policies should we be shaping and making. So best way to get involved in all of that is LinkedIn and then our newsletter on our website.
Julia, thank you so much for your time today. Really appreciate it.
Thanks, Cody. This was a blast and really appreciate the invitation.
Thanks again for joining us on the My Climate Journey podcast.
At MCJ Collective, we're all about powering collective innovation for climate solutions by breaking down silos and unleashing problem-solving capacity.
If you'd like to learn more about MCJ Collective, visit us at mcjcollective.com. And if you have a guest suggestion, let us know that via Twitter at MCJPod.
For weekly climate op-eds, jobs, community events, and investment announcements from our MCJ venture funds, be sure to subscribe to our newsletter on our website.
Thanks, and see you next episode.